All right. Thank you all for coming. I have the coveted post-lunch slot, so right now probably everyone's still in the process of digesting, hitting that afternoon slump. So I'm going to do my best to get you all energized. We're going to start with a little bit of some stretching. I'm going to ask you a few questions. So raise your hand if you speak a language other than English. Okay. Any language other than English. I don't see as many people raising their hands as I expect. So I'm going to ask that again. I know some people are tired, but let's just make sure. Raise your hands if you speak a language that is not English. Any language that's not English. In addition to English, but yeah, okay, that seems a little bit more what I would have expected. So, okay, let me put this up a little bit. Now raise your hand if English is not your first language. Okay, that's, again, most people here. And now raise your hand if you don't speak English at all. That's not actually a trick question. Sometimes I ask this question at not this conference, but other places where you actually have live translation. So sometimes it is true that you'll see people who who actually don't speak English at all, but still understand it. But that was just to make sure you all are awake. So my name is Aditya, and I'm an observability engineer at Stripe. And this talk is titled Goro, translating Go to other human languages and back again. So it's about a project I wrote to translate Go into other languages, but more broadly, it's about making computer programming accessible to people who don't speak English. So, I can speak a few different languages, but, Vietnamese is not actually one of them. But even though I don't speak Vietnamese, that doesn't mean that you or I shouldn't be able to collaborate together on projects. And this is something that's, there's a question that's particularly relevant to Go because Go has a fairly wide user base from all around the world, and it is actually a language that's fairly well suited to suiting the needs of people who speak languages other than English, and we'll get into some of why that happens a little bit later. But so I've been writing Go full time for I think 7 years now, and a lot has changed actually in that time. With how we view language barriers in Go as a programming language. So this is from the source code of the Go language and from the Go 1.0 compiler back in 2012. So if you don't write C, then there's probably a lot of unfamiliar stuff there. You might be able to get a sense of what's happening if you write Go and don't write C, but not completely. And it would be much harder to actually write this and recreate it yourself than to read it. C in particular is a very difficult language to write and to write safely if you don't actually know C, because even experienced C programmers can't write C safely. So if you're not a C programmer, you might really not want to try, at least without learning. So yeah, we get the gist of what's going on here, but it's still not completely familiar to us as Go programmers, unless you happen to have a C background. And so this was a huge barrier to contributing to the Go project, and everyone recognized that. I mean, think about it. We're here to contribute to the Go project. We already know and use Go, so why should we have to learn a whole different language, C, just to do that? And so to address that issue, we actually rewrote the whole Go compiler from C to Go, and that was released in 2015. So we did that largely with a C to Go translator that translated the code automatically, and then the remainder was done by hand, like little fine-tuning fixes here and there. And so there's a great talk from the very first GopherCon about this. But that only actually removes one language barrier, and there's still one more to contributing to Go. Go development happens almost entirely in English. That's true both of the official Go project and also of popular projects that use Go, like Docker, Kubernetes, Grafana, Console, and so forth. Those are all, the development for that is all done in English. And so a person's ability to contribute to these projects is greatly limited if they don't actually have a working grasp of English. Even reading the code, like understanding the word char and understanding what like scale mean, that's something that you and I might take for granted, but for some people, even reading the Latin script is an extra challenge. That's something that, as people who speak Vietnamese is probably not as big of a deal because Vietnamese is actually at least is written in the Latin script. But for the majority of languages in the world, they don't actually use the Latin script, and so even just understanding those letters and stringing them together, that's an additional barrier. And so since computers are here to make our lives easier, let's see what computers can actually do about that. So in the Go community, we already have a lot of people who don't speak English as their first language, as we saw in this room. We also have a lot of people who don't speak English very fluently, and we actually even have some people who don't speak English at all. So for example, the Chinese Go community has actually translated the official Go documentation into Chinese, complete with the iconic Go for mascot. And there are other projects that you can actually find on GitHub in which the README, the documents, the README, the comments, and the issue tracking actually all happen in Chinese. And there are even some Go conferences, like GopherCon Brazil, which are bilingual conferences. In Brazil, there are actually talks. There are separate talks. Some talks are in English, and some talks are in Portuguese to cater to both audience members but also to speakers who have different degrees of fluency with English. And some people might feel more comfortable presenting in one language or the other. So it's actually interesting. The first time I talked about translating Go to other languages was probably 3 or 4 years ago now at this point. And even in that time, we've actually seen an increase in the number of communities like this that cater to people of different different linguistic backgrounds, people who speak one specific language that isn't English more than they speak English. So it's great that Chinese and Brazilian Gophers have developed these thriving communities for themselves, but fragmenting resources is bad for open source development. Fragmentation means duplicated work and incompatible interfaces. So how might we bridge these communities better? So one possible approach is to use a common language, which is also known as a lingua franca. If we wanted to standardize around a common language, English would be the reasonable choice because it's already so widely used by open source projects. But that poses some problems. First, English is difficult to learn. Objectively, that's why we have the situation we're in now, where it's actually easier for many non-speakers and non-native speakers to build their own communities from scratch than it is to participate in existing English-speaking ones. They go through all that extra work because that language is that high of a barrier. But secondly, even if everyone could just learn English, non-native speakers are always going to be experiencing a language barrier that native speakers aren't. And so that goes against our goal of defragmenting open source software and putting everyone on the same level playing field. But finally, we think of English as a single language, but in reality, there are actually many different dialects and registers to English. And if our solution is to use a single language, we'd have to standardize around a single dialect and register of English as well, and that's impossible because languages grow, they evolve. And this is actually the reason that the very first lingua franca means the Frankic language. It referred to Sabir, a language that was actually spoken throughout the Mediterranean. And that language was basically a mixture of what we would consider Spanish, French, Portuguese, Italian, a number of different Mediterranean languages. And what happened to it? Well, it actually died out. As its usage grew across the Mediterranean, it actually fragmented and it ended up basically diverging and influencing those local languages that we have today, like Portuguese and Italian and Spanish. And that's what languages do. That's languages since the very beginning of human language, as far as we know. They grow, they evolve, they adapt, they change form, and we can't fight that. That's not something that we have the ability to control. That's how languages fundamentally work. So it's much better for us to embrace multilingual workflows instead of fighting an uphill battle against linguistic divergence. And it's no secret that that's what we do already for programming languages. Like we don't specify that everyone has to learn one single programming language to use in all different environments. Even the closest thing that some people would probably say we have to that, like JavaScript. JavaScript is one of the few languages that can be used on a very wide range of platforms. It started off as LiveScript used in the browser, but these days it's used server-side, and it's even used for, weirdly enough, systems programming. Like if you want to write, if you want to change networking and permissioning rules at a low level in Linux, you actually have to write your rules in JavaScript. Try telling that to someone like 15, 20 years ago, they would have thought you were crazy. But even JavaScript, it's not actually a single language anymore. JavaScript as it exists in the browser is a fundamentally different language from JavaScript as it's written on the server in Node.js. There's a lot of overlap. If you know one, you can write the other one fairly easily, but they're not actually the same language. There are a lot of differences, or at least they're different dialects of the same language. And as JavaScript's become more popular, we've created variants of it that are more tailored to different use cases. React might as well be considered a different dialect, almost a different language altogether, because of the way that it mixes JavaScript with XML. Like we'd consider that, in linguistics, you might consider that a Creole. And we have something like TypeScript, which is created to solve issues that exist within the JavaScript community and is fundamentally actually just a different language altogether. So we see that as a language grows in popularity, there is a need for it to grow and adapt and evolve, and therefore to fragment. And so with programming languages, we already accept this, and we already have ways to account for that. We now just need to understand how to do that for human languages as well, the languages that we use to communicate with each other as human beings, instead of communicating just with the computer. The idea of eliminating natural language barriers to programming isn't new at all. In fact, it's very old. Grace Hopper was one of the very first computer scientists, and she wrote the very first compiler for a programming language. The language that she invented was called COBOL, and the goal was to have English-like natural language syntax so that business executives could write code. And she received incredible pushback about this because engineers are furious. They thought that if non-engineers could write code, well, that could put them out of a job. But Hopper's vision actually took this even further. Why restrict this to English-like syntax? What if engineers who spoke other languages also wanted to write programs? She wanted COBOL to be, and I quote, "a language you can use to talk to programmers around the world." And the response to that was even more vitriolic, because people just said, well, how can we teach American computers to run German programs? And to be clear, this wasn't a question of how that could be done technically. It was very much a political question, because it was a decade and a half after World War II, but really only a decade and a half. So the fear of a threat from Germany or Russia was still a pretty big threat in people's minds, in the US military at that time. So Hopper's idea was put on the back burner due to xenophobia and politics back in the 1950s. But we can look at that today and we can look at what that idea, that vision means today, and learn from its approach. So this is Hopper speaking about COBOL many years later after she retired. She said, "I would have thought it would be useful to NATO because they had the common verbs for the things they were going to do, and the nouns. They would just have to have a dictionary for things that they were referring to for inventory control. They'd have common nouns throughout NATO, and they could make a dictionary of the common verbs and translate the program. You could write one in English and you could translate it and it would go to the other language. No problem, you'd have communication. It would be a limited vocabulary. NATO, of course, being the alliance of militaries from different countries, so who of course speak very different languages, and so this idea that you have a common, you already have this common set of verbs that exists across these allied militaries, and then just needing to have a dictionary to translate them. It's fairly simple, but also fairly powerful. And as an interesting side note, Hopper chose the imperative mood, like the imperative form in English being, when you command someone, like saying, write this, do this, execute this, as opposed to declarative, which is like, it does this, it writes this, it executes this. She chose that imperative mood because she believed that it would be universal to all languages. Not all languages distinguish between the past, the present, and the future tenses. At least they don't do so quite so distinctly. I'm not actually entirely sure about Vietnamese. I know that Chinese, it's much more limited in the ways that tense distinctions are used. Even in Bengali, in our language that my family speaks, tenses and singulars and plurals are actually much more mixed together. But languages generally have a way of commanding people to do something. That's probably like one of the first uses of language was to tell people what they needed to do. And so COBOL was one of the first languages which popularized imperative programming styles. And so that's actually stuck with us to this day. That's one of the, even in Go, function names are usually done in the imperative. And that's indirectly a result of this tradition which Grace Hopper started. Go also takes, if I can digress for just a moment, one other inspiration from COBOL. Does anyone know what it is? A very direct inspiration from COBOL. Any? It's the time parsing library. Go's time parsing library was actually very explicitly designed after COBOL's. So if you love it, you can thank COBOL. If you hate it, then I guess you can also blame COBOL as well. But so going back to the topic you have at hand, let's see what we get when we take these techniques that we use to translate the Go compiler from C to Go and then apply that to Hopper's vision specifically. So enter Goro. Goro is an extension of the Go compiler and toolchain to support Bengali. The name Goro is an idiomatic translation of the English name Go. And I chose Bengali for a number of reasons. First of all, it's a language that my family speaks, so I have a personal connection to it, and it's a language I can understand. It's also a very common language. After Hindi, it's the most common language spoken in India, and it's the national language of Bangladesh as well, which combined makes it the 7th most widely spoken language in the entire world. That puts it far ahead of many European languages as well that people think of as commonly spoken languages, like way ahead of French, Portuguese, Italian. But it's also, interestingly, a non-Latin script that has, I'll kind of abuse the word, diacritic. It has marks attached to letters. So I'll break this down. Let's see, do I have a pointer thing on this? No, not really. I'll break this down for you a little bit there. That first symbol that looks like a triangle and then that second symbol that also looks like a triangle, those are both letters. The curly thing and then the line after it, those are actually modifiers that are attached to letters that are actually vowel signs. And those are combined in a way that similar to the way that accent marks in a language like French or even Vietnamese to denote either accents or vowel sounds. Those are added combined to letters, but it's in a non-Latin script, and so that makes it a little bit more difficult. Computers aren't necessarily as used to dealing with non-Latin scripts as they are to dealing with Latin scripts. And so that makes it an extra challenge. Can we do this with Bengali? If we can do this with Bengali, then that gives us hope that we can do this in a lot of other languages as well. But of course, nothing that I'm going to talk, I'm using Bengali as an example because of all these reasons and because, most importantly, it's a language that I'm familiar with, but nothing I'm presenting here is unique to Bengali. So, I'd encourage you to do this with your own languages, whether that's Vietnamese or whether you also speak another language in addition to that. Go ahead and actually try this out. So this right here is a familiar HelloWorld program written in Go. Nothing particularly out of the ordinary here for this conference anyway. And then this is that equivalent program that's written in Goro. So we've left the identifier names intact, like the main, but the keywords are all now in Bengali. And you'll notice I did not actually forget true. True is not actually a keyword in Go. People are sometimes surprised to learn that, but it's not actually a keyword. It's built into the language, but it's actually defined as a variable or an identifier. Sorry, a variable, not an identifier. So, but right there, that's the package that basically means that next word means basically import. I've abbreviated that there. That's basically the way we say func. That's basically an F, the F sound. But the first challenge we have here is we need to actually get this program to run, because it's all very well and good for me to stand up here and tell you that this does the same thing and translate this for you on the fly, but the standard Go compiler isn't going to know what to do with these keywords if we feed it to it. So quick show of hands, how many of you are familiar with what a lexer and a parser are? Anyone? Okay, only a couple of you. That's to be expected. To be honest, I mean, unless you're at like a compiler design conference, most people probably have never had to deal with this in their lives because thankfully we have high-level programming languages these days, so most people don't need to write their own compilers anymore. So a very brief explanation, a compiler is divided into multiple stages. The first stage you have is the lexer. A lexer is just taking, like individual tokens, and you can think of it as like basically the words in a language, and it's just mapping those to symbols internally. But every single token or like every single word gets its own symbol. And then the next stage is the parser. That's where you're actually applying grammatical meaning to a word. You're actually saying, okay, fine, we're combining different words together. We're combining these tokens. What do these tokens actually mean when you put them in a sentence together? And so this is actually something which is done in the study of natural languages as well. And so it applies pretty readily to programming languages. And so Go's source code is all UTF-8 by definition, which means that the compiler actually has no trouble dealing with non-ASCII characters in Go programs. And as we saw at the beginning, the Go compiler itself is actually written in Go, which means that the Go compiler has no trouble inherently dealing with non-ASCII keyword definitions, because it already can deal with non-ASCII Go source code, and that's all that the Go compiler is now. There are a couple of internal tests in the testing library that are in the integration tests in Go that check that non-Latin and non-alphabetic characters aren't used in keywords, but that's literally all those tests do. So you can actually just disable or like delete those tests, and everything else will work just fine. So all we have to do is then extend the lexer to include the Bengali translations of each keyword as well. So right there, that first word, if in the English version of the Go compiler, that would have been break, which gets mapped to L break. It's the L doesn't mean anything. It's just it just means that that's what the lexer is. It's an internal constant. And so all of these keywords, we just needed to translate those strings from English into Bengali. It's a very easy addition. We're actually not replacing them, we're adding them for reasons that I probably won't get into, but are actually kind of boring. It's easier to add new definitions that add multiple different variations of keywords that mean the same thing than it is to replace them altogether. So, but the key thing to understand here is this is actually all done purely by the lexer. The parser, which is understanding the meaning, which is responsible for piecing together the meaning of programs, that has no idea that anything's even changed. It actually still sees the exact same input. The lexer outputs the same thing no matter what, so the rest of the compiler pipeline is untouched. And so that's actually not something you can do easily in most other languages, because most other languages like Python, JavaScript, they all use flex-based lexers. Flex is the GNU lexer that's been popular for the last 40 years. But unfortunately, Lex or Flex doesn't support multi-byte code points. It was developed in an ASCII world. And Go was, being a new programming language, wrote its own lexer from scratch. So there's a reason that I'm giving this talk at a Go conference and not at a Python conference. It's true, I love Go. I've been writing it for over 7 years as my primary language, but this is actually literally not something that you can do in Python, or at least not so easily. You'd have to start munging around in the parser, and parsers are much more complicated. There's a lot more stuff that you would need to modify. It's certainly a lot more than just updating a single map in one file. So even even if we were talking about doing this in the original Go compiler written in C, this would have been much harder. I actually tried this project back in 2014 when the Go compiler was still written in C, and let me tell you, it was a lot easier when I came back to it a year later after the transition to Go, was it 1.4 or 1.5 had been made. So I'll just mention that some of these translations were kind of straightforward, but some of them were really fun, like the word fall through. Like, how do you translate what fall through means into a different language? Do you try to go with something that's literal, or do you try to come up with a different metaphor that conveys the same meaning? For those of you who speak languages other than English, which is most people in this audience, try and think how you might translate Go keywords into those languages. It can be a fun and kind of entertaining exercise. If you have thoughts on this, come talk to me afterwards. I'm curious what you come up with. So having made these changes, here's what that HelloWorld program looks like in practice. So I'm just outputting that program, and there we go. We run it. So we are now able to actually run this program that's written in a non-English dialect of Go. But remember, our goal is to defragment the open source community, not to fragment it further. So we want to make sure our code is interoperable with code written by English-speaking Go developers. And we don't want to have to translate every program manually. But thankfully, for the translation step, Go already has a handy utility for formatting source code called GoFormat or GoFum, depending on who you ask. And mostly we use it to prevent bike shedding over things like the tab versus spaces argument. So instead of arguing over the proper way to format source code, everyone could just set up their editor the way they want. So if I want to use 4 spaces for indentation and you want to use 2 spaces, GoFormat still means we can work together. We don't that's not an irreconcilable difference. We just each set up our editors to render tabs with the width that we want, and after we save our code, we run GoFormat, and it will automatically translate our code to the standard style with no work needed. And in fact, we don't even need to be aware that we have different indentation preferences, because the code that gets committed to source control is in the standard form, and it's just up to our editors that display it in our preferred forms. But GoFormat can actually handle a lot more as well, like removing unnecessary parentheses. And it's syntax aware, so it's smart enough that it will never change the code semantics, which is a simple way of saying a very fancy concept, which is that it's a great way for performing fully isomorphic translations of source code. Isomorphic meaning you take source code and you translate it to something else that is equivalent. It's one-to-one. It does the exact same thing. So we can actually extend GoFormat and repurpose it for translating English Go code into Bengali or Bengali Go code into English. And that's what Goro format does. So let's translate Goro back into English Go. So here we go. We start off with the Bengali HelloWorld program, and now we run Goro format, and you can see you get some English output. But let's say you don't believe me. You want to actually see, does this actually execute identically? So we translate it, and then we run it. So now we have actually taken a program that's written in a non-English dialect of Go, run it in that dialect's compiler, translated it into English, and run it using the standard Go compiler as well. We've actually translated code from one human language to another. Pretty impressive, right? Come on, I think that's worth like some applause there. Yeah. It's like, I know you guys are asleep, but like we can. So the same way that you didn't know that I was using 4 spaces and that I didn't know that you were using 2, having bidirectional translation layers means that you don't need to know that I'm writing my code in English, and I don't need to know that you're writing your code in Bengali or in Vietnamese or in Spanish or really any language under the sun. We can localize our code as a commit hook the same way we already do for formatting source code. And so as a developer, Goro means that you only ever need to be able to look at source code in your own language. As far as the code is concerned, our language preferences are no more of a barrier between you and me than our indentation preferences are. And that's the way it should be. So the billion-dollar question that you've probably been wondering for a while, can we do this in Vietnamese? I see one person shaking their head. No? Think this can't be done? I think it can be done. I mean, I actually posed this question to a JavaScript conference a few months ago, because I was told that the best way to get JavaScript programmers to do something is to tell them that they can't do it in JavaScript, and then by the end of the talk, like someone will have proven you wrong. I don't know. I don't know if that works. I think Go programmers are a little bit different like that. Where rather than going with this like reverse psychology approach, I'll say, I think this can be done. I think that we have enough people in this audience that I wouldn't be surprised if by the end of today someone's actually taken Goro and given that a shot with Vietnamese. If you need any help with that, come talk to me. I'm more than happy to lend you a hand. It's really a lot simpler than it seems, and it's a great way to understand some of the internals of how the Go compiler actually works, if that's something that's interesting to you. So we've translated here the keywords, but you'll notice that we didn't touch everything. Like we didn't touch the package or the variable names. There's a lot that's been written on the topic of choosing good variable names, and the one thing that pretty much everyone agrees on is that they should be both descriptive and concise. But of course, if we leave the names in English, as most open source projects do, that's not very descriptive to someone who doesn't speak English. Is there a way that we can translate these as well? Well, in reality, many variable and function names are actually already highly structured. Because as Hopper mentioned, we already have the verbs that we use quite frequently when we write code. So we can take advantage of this knowledge and translate these in the translation step as well. You'll see here that we read foo, write foo. These are common idioms that already exist throughout both the Go standard library and also just Go packages in the wild. And Go format already gives us the building blocks to make renaming transformations like these. With Go format, the -r flag that you can pass to it. So by being just a little bit more concise about the conventions we're already using, we can make our code much more accessible to non-English speakers. Non-English speakers. We might not get all the translations for free, but we can get many of them. Right there, you can say fu poro, fu lekho, or bondo. Like, for someone who speaks Bengali, we can't translate the foo, but it's certainly a lot better to actually see that this this has something to do with reading, something to do with writing, and then pattern matching the rest of it. That's a lot more accessible to someone who doesn't speak English as their native language than the first half is. And we can do this fairly easily because, as Hopper mentioned, we already have the verbs that we use very commonly when we write code. We just need to be aware of that and take advantage of it. In the interest of time, I'll cover this part just a little bit quickly. If you're curious more about this, you can come talk to me afterwards. But in short, for many of us, coming to Go meant getting used to a completely different strategy for error handling. So instead of throwing exceptions, we return errors, which takes some getting used to, but eventually we learned that there are some amazing advantages to this approach, as Rob Pike talked about in his blog post called Errors or Values. Errors or values as a principle means a lot of things. It means that we can assign the return value of a function, which is an error, to a variable and then operate on that as a first-class citizen of the language. It means we can store it on a struct to record it, like the scanner struct in the standard library does, or we can ask it what other interface types it satisfies. Go's error handling is actually probably the most expressive error handling system of any language I've ever used. It's probably right up there with Common Lisp in terms of how expressive its error handling is. I've spoken actually about error interface types and error handling at other conferences in the past. So if you're interested in hearing more about that, you can check those videos out. But treating errors as values gives us something very interesting in the context of translating languages, because we can localize our error messages. In Go, the string that's returned by the error method is the only value that you can guarantee exists on every single error that you get. And so it's considered bad form to try and parse this error string by hand. And I would agree strongly with that advice. If you find yourself doing string parsing on an error string, there's probably something wrong with the design of the code that you're dealing with. But because it's bad form to parse it automatically, that makes it all the more important for us to be able to render error messages in a way that's readable and interpretable to the end developer, whatever language that they happen to speak. Because as developers, we've all struggled with cryptic error messages. Go, this is one of my favorites from Java. This is actually a real error message that you can get if you're programming in Java. Cannot cast parameter type from type system.string to argument type system.string. This error message is so cryptic that I have absolutely no idea what it even means anymore. And I've been using this as an example of a bad error message for so long that I've actually forgotten. So if any of you write Java and know what this error message means, please tell me, because I would love to know. And so error messages are the easiest for us to solve technically, because we can use existing localization strategies for translating and localizing error messages from one language to another. Because the only thing that's worse than a cryptic error message is a cryptic error message in a foreign language that you can't understand. Documentation, remember our goal is to do this automatically. And so translating error messages by hand is fine, but documentation gets to be a little bit trickier. And I'm sure that I'm not the only one who's amused themselves by using Google Translate or Babelfish to see how machine-generated translations will stumble over idioms. But it turns out that tools like Google Translate can actually work quite well for technical documentation. Because like the C2Go compiler, C2Go translator, which was written to translate a specific subset of C, machine-generated translations are written to deal with a very specific subset of languages. And technical documentation are actually that restricted subset. It's not the whole set of all English language that we're looking to translate. It's the kind of English that's written in technical documentation, which actually tends to translate pretty well. Again, in the interest of time, I'm going to skip over this pretty quickly, but if you're interested, I'll post the slides later. You can actually take this documentation from English, translate it into Bengali, and then actually translate that Bengali back into English. And it's not great, but you actually do get the gist of it. It kind of comes through. The information is copied directly from the corresponding text or text. There are no internal buffers. It's like, yeah, it's not perfect, but it does get the point across. And you can, in fact, do that through an additional language step. So this was English to Spanish, Spanish to Bengali, Bengali to English. And it turns out that actually also works. Again, not great, but not as much lost in translation, not as much information lost in translation as you'd think. But the key thing here is that with automatic translation, you have to plant the seed. You're signaling that you're opening your project up to a multilingual workflow. This stuff doesn't happen automatically. We have to commit ourselves to working with developers across language boundaries. And that's actually the hard part, making that commitment and sticking to it. I'm going to skip over this. So there are a lot of different steps that we could take to including non-English speakers more in open source Go development. and making tool chains for translating code, translating tools, code, and documentation for other languages, like we saw here with Goro, that's just one of them. And so if anyone's interested in going home and making a variant of Go like Goro for Vietnamese or for another language, again, I'd really encourage you to do that. Tag me on Twitter. I'd love to see it. And so some of these things involve building new technology and tools to solve the problem, but others are straightforward and low tech, and they involve the way that we operate as a community. And we have to remember why this actually matters. 95% of the world doesn't actually speak English as their first language, and 89% of the world doesn't speak English at all, at least not with any degree of fluency. And we saw that here, to a degree. A lot of people, the majority of this room doesn't speak English as their first language. Of course, the majority of this room does speak English, so in that sense, we're not representative of the world at large. We're actually, we're in a better spot than most people here. If this conference were perfectly representative of this world in every way, only a very small handful of people would be probably basically this front row would actually be able to understand this talk. So GopherCon Vietnam is itself a piece of the puzzle, opening up the Go community to people who come from different language backgrounds, but it's only one piece of the puzzle. So between being written in UTF-8, having native support for UTF-8 and being a bootstrapped language and having Go format, and then also having this large community of bilingual speakers, there's no other language that's really as well suited as Go is to being used by the entire world, not just by those 5 to 10% who speak English. So we have the opportunity as Go programmers to bridge the language divide in a way that no other programming language has ever done before. So let's do that. Let's commit ourselves to making Go the first programming language that's truly accessible to everyone, no matter what language that you speak. Thank you.